right, guys, today I wanted to go over kind of a different usage of the medication Viagra compared to what people usually think of it being prescribed for, which is erectile dysfunction, and kind of relate that to why the heck would climbers on Mount Everest be given Viagra by a base camp provider, and why that relates to your lungs and something called high altitude pulmonary edema. It's pretty cool. So if that sounds interesting, let's hop into it. So Viagra, we all know, is the erectile dysfunction med. It is under the class of a PDE5 inhibitor. Blah, blah, blah. What does that mean? Well, PDE5 inhibitor, the end result is it is a vasodilator. You can imagine what region it dilates and why that is used for erectile dysfunction. However, shifting gears in a much cooler mechanism, let's go over acute mountain sickness and high altitude issues. So over here, we have Mount Everest, okay? So Mount Everest, let's call it 30,000 feet. Okay, and then we have some guy standing at the top of Mount Everest. One of the problems at being at high altitude, and the reason a lot of these people have oxygen, is the fact that when you are so high up, the column of oxygen that exists in the atmosphere, basically the higher up you are, you actually have a lower partial pressure of oxygen, your PO2. It's not the percentage of oxygen. The percentage is the same throughout the atmosphere. You have a less pressure of oxygen, effectively a shorter column pushing on your head. Look at it this way. If you're in a swimming pool, say you're at the bottom of a swimming pool, you're going to have a column of fluid, which is water. You're going to have a large column of water pushing on your head. You're going to have a lot of pressure. Your head hurts when you're swimming at the bottom because there's a larger pressure exerted on you. If you were at the top just floating on a nice summer day, your head doesn't hurt, right? Because you don't have a column of fluid pushing against your head. The opposite is true on Mount Everest. At sea level, you have a larger column of oxygen, which is a fluid, a larger partial pressure, which makes it easier to get into your bloodstream, essentially. At the top of Everest, you have a shorter column of oxygen, hence a lower partial pressure. What does that do, guys? Well, that leads to hypoxia. Okay, hypoxia is low oxygen, partial pressure, but low oxygen throughout your body, right? Let's zoom in over here. Here's a lung, a little cartoon of a lung, and then I drew a simplified alveoli, which is the air sacs that make up your lung. They're everywhere. There's tons of them, a lot of surface area, a lot of blood vessels, which is why I drew it like this. The whole purpose of your alveoli, and think of breathing. I mean, why do you breathe? It's because of gas exchange. What is gas exchange? You all probably know this. When you inhale, the biggest reason you inhale is you are pulling oxygen into the airspace, which can then diffuse into your red blood cells. In the same opposite motion, when you exhale, you're taking the CO2 that's in your bloodstream that gets produced by your tissues, your metabolic tissues, and you exhale CO2, right? Bring oxygen in, get rid of CO2. That is gas exchange. That is the essence of what your lungs do. However, the complication of high altitude, hypoxia at high altitude, because of the lower pressure of oxygen, one thing that happens is you vasoconstrict. Sorry, that's in the... Okay, vasoconstriction, okay? And this is not good. Vasoconstriction basically means in your blood vessels, these are your red blood cells that pass single file through your capillaries. They're moving in this direction. However, because under hypoxic conditions, you  let's just pick this as the point of vasoconstriction in your blood vessel. look at what happens to that tube, okay? It's going to be a lot harder for your blood because of the pressure to pass this direction. One of the consequences, because of that resistance, because of hypoxia, it vasoconstricts throughout all of your lungs, is in your blood. And I drew the red blood cells, but that's only about half of what your blood is. Most of your, like half of your blood is water from your plasma. Because it can't go this way, it's going to start backing up. And the fluid in your blood, the plasma fluid, which is basically water, is actually going to start accumulating in between your blood vessels and the alveoli in your lungs, and even get into your lungs. And by the way, this is actually kind of a similar thing that happens to coronavirus patients, COVID patients. Not the same, but in terms of gas exchange, it's similar pathology. Because you have all of this fluid, which is mainly water, because of this vasoconstriction, because it constricts and the back pressure pushes fluid back out into your lungs, you're going to get something called, this is an example of pulmonary hypertension, okay, which is high blood pressure, right? Because it's so constricted, the pressure's so high that it starts pushing back into your lungs. The complication at high altitude, because of this fluid shift, is something called high altitude pulmonary edema, okay? This is why you're giving Viagra. So Viagra is a vasodilator. Okay. Oh, and by the way, because you have fluid in here and you impair gas exchange, okay, you're impairing gas exchange. I mean, patients are going to feel like crap, right? Their oxygen saturation sucks. They're short of breath. Their respiration rate is probably high. They're breathing really hard. Their heart rate is pumping harder. I mean, there's so many, it's a bad vicious cycle when you start influencing the heart and lungs. Because Viagra is a vasodilator, it actually can work in the lungs. And that smooth muscle contraction that I just showed that made this vessel more narrow, it can actually kind of bring it back to normal. And what that kind of does is, look, because you have that fluid shift, which is the peripheral, the pulmonary edema, edema just means like a fluid shift, because you're now opening up these vessels, increasing the area, dropping the pressure, you're dropping the pressure in your lungs. You're allowing this fluid to actually get pulled back into circulation where it should be, right? So you're going to lower the blood pressure. You're going to increase gas exchange, which is what you want for these people on Everest, right? Because, gosh, they're already at high altitudes. They're working really hard. Now you're interfering with oxygen and CO2 movement. That's terrible. You want to bring that back to normal. You drop the pressure with Viagra in the lungs. You increase gas exchange. You try to bring these symptoms back to baseline. That is one of the uses of Viagra, and it's pretty cool because not a lot of people really talk about that. And I actually know 2 patients, both females, who have pulmonary hypertension, not due to high altitude, due to other reasons, and they both take Viagra each day, and they seem to be breathing fine. So it's kind of an interesting usage, and I just wanted to go over some pulmonary mechanics, high altitude medicine. And on that note, guys, I hope you guys have a great day. Happy quarantining.